Hello, my dear children. Welcome to the mathematics class. Today we are going to discuss circles. In this chapter, we are going to discuss the concepts of exercise 10.2. In the previous exercise, we have discussed the concepts of 10.1 exercise. In that exercise, we have discussed the terms. We have defined a circle and the terms related to a circle. I hope you have learnt well. I hope you have understood well and you have learnt well. Haven't you, my dear children? Right. Now come to this exercise 10.2 concepts. Are you ready to listen the class? Right. See the first point, angle subtended by a chord at a point. Okay, my children. Before going to define the angle subtended by a chord at a point, first let us define the angle subtended by a line segment at a point. Okay, my children. See, take a line segment PQ. Here we have taken a line segment and a point R not on the line segment to PQ. Here a point R is taken which is not lying on the line segment to PQ. Understood this point, my children? Right. Join PR and QR. We have joined these 2 points and these 2 points. Okay, my children. Then an angle is formed here. Yes or no, my children? An angle is formed at this point R. See the figure 1 given below. Then angle PRQ. Angle PRQ is called the angle subtended by the line segment PQ at the point R. Understood this point, my children? This angle PRQ, this angle is said to be the angle subtended by this line segment PQ at the point R. Is this point clear, my dear children? Right. Now observe this figure, my dear children. This is a circle with a center O. This is a circle with a center O and PQ is a chord. Okay, my dear children, PQ is a chord. In the above figure, O is the center of the circle and PQ is a chord of the circle. Okay, my dear children. Then angle POQ. Here, O is not lying on the line segment PQ. Then angle POQ is called angle subtended or angle made by the chord PQ at the center O. Okay, my dear children, understood this point? Same as the previous point. We are connecting that previous knowledge to this concept. So, angle POQ is called the angle subtended or made by the chord PQ at the center at this point O. Understood this point, my children? Similarly, angle PRQ, here a point R also not lying on this line segment. Angle PRQ is an angle made by or subtended by this chord at point R. Similarly, this point S, at point S also angle is made. The angle PSQ is also said to be the angle made by the chord or subtended by the chord PQ. Where the point lies, this point are on major arc. Yes or no, my children? This point S is lying on minor arc. So, angle PRQ and angle PSQ are respectively the angles subtended by the chord PQ at points R and S on the major and minor arcs PQ. Is this point clear, my dear children? Right. Now come to the theorem 10.1. Theorem number 10.1. Equal chords of a circle subtend equal angles at the center. This is a theorem 10.1. If there are two equal chords, there are two chords of equal length of a circle, then they subtend equal angles at the center. Okay, my children, let us prove this theorem. See this figure. In this figure, let O be the center of the circle and AB and CD are of equal lengths. These are chords of the circle. Okay, my children. Let O be the center OB the center, and AB and CD are two chords of the circle of equal length. That is AB is equal to CD. Okay, my children, we have taken two chords, namely AB and CD. These two chords are of equal length. That is equal to AB is equal to CD. Understood this point, my children? Right. We have to prove that required to prove. What is to be required? Angle AOB is equal to angle COD. Okay, my children? Right. So for that, join AO, BO. Okay, my children? Join AO, BO and CO, DO. Then we got two triangles, namely OAB and OCD. Okay, my children? Then we get two triangles, namely triangle OAB and triangle OCD. Understood this step, my children? After joining AO and BO, CO and DO, we got two triangles, namely OAB and OCD. Yes or no, my children? Right. In these two triangles, in triangle OAB and triangle OCD, OA is equal to OC. Yes or no, my children? Because they are ready. OA is equal to OC. Radii of the circle. Yes or no, my children? Similarly, OB is equal to OD. OB is equal to OD. These are also radii. These are also radii of the circle. Now, AB is equal to CD. We have already taken like this. AB is equal to CD. Given. It is already given. Okay, my children. So, in these two triangles, three sides in this triangle are equal to the corresponding three sides in the second triangle. Then we can say that triangle OAB triangle OAB is congruent to triangle OCD by SSS congruence rule. Do you remember this congruence rule, my dear children? Yes, by using this congruence rule, we have proved that these two triangles are congruent triangle. Understood this step, my dear children? Right. So, by CPCT, angle AOB is equal to angle COD. Yes or no, my dear children? Therefore, angle AOB is equal to angle COD by CPCT. What is meant by CPCT? Do you remember the full form of this CPCT, my children? Yes. Corresponding parts of congruent triangles. Do you remember that full sentence, my children? Corresponding parts of congruent triangles. So, by CPCT, we can say that angle AOB is equal to angle COD. Hence proved. Is it clear, my dear children? Right. Now come to the next theorem 10.2. Theorem 10.2. If the angles subtended by the chords of a circle at the center are equal, then the chords are equal. Understood this point, my children? If the angles subtended by the chords of a circle at the center are equal, if the angles are equal, then the two chords are said to be equal. This theorem is converse of the theorem 10.1. Understood, my dear children? Right. Now come to the question number 1. The concepts of exercise 10.2 were completed. Okay, my dear children. Now let us start the sums in the exercise 10.2. Page number 173 in the textbook. Okay, my dear children. Right. Come to the question number 1. Recall that two circles are congruent if they have the same radii. Okay, my dear children, do you remember this point? If two circles are of equal radii, the two circles are said to be congruent. Okay, my dear children, prove that equal chords of congruent circles subtend equal angles at their centers. Okay, my dear children, we have to prove that the equal chords of congruent circles subtend equal angles at their centers. Understood this point, my dear children? Understood this question? Right. Now come to the solution part. Let us assume that the centers of these two circles are O and O dash, and these two circles are congruent circles, means their radii are equal, means OA is equal to OB is equal to OC is equal to OD. Understood this point, my dear children? Right. Now we have to prove that angle AOB is equal to angle COD. Okay, my dear children. So let us assume that let O and O dash are centers of centers of centers of congruent circles. AB chords AB and CD are equal. Let the chords AB and are equal length. That is AB is equal to CD. Okay, my children, we have taken like this. AB chord, CD chord lengths are equal. Okay, my children, understood this point? Right. Required to prove. What is to be proved? Angle AOB is equal to angle COD. Okay, my children, understood? Now join AO, BO, join AO, BO, CO dash and DO dash or O dash D. Okay, my children, DO dash. Then we get two triangles. Then we get two triangles. Namely, triangle OAB and O dash CD. Triangle OAB and triangle O dash CD. Understood this point, my children? We have joined AO, BO, CO dash and DO dash. Then we got two triangles, namely triangle OAB, triangle O dash CD. Okay, my children, understood this point? Understood this step? Right. In these two triangles, in triangle OAB and a triangle O dash CD. OA is equal to OC. They are equal. AB is equal to CD. And these are radius of the congruent circles. Okay, my children. Radii of so their radii are equal. Understood this point, my children? Right. Similarly, OB is equal to OD. OB is equal to OB is equal to O dash D. These are also radii of congruent circles. So OB and O dash D are also equal. And AB is equal to CD. We have taken. It is given. Okay, my children. AB is equal to CD. So we have compared the three sides of this triangle with the three sides of this second triangle. They are equal. Corresponding sides are equal. Then we can say that triangle OAB is congruent to triangle O dash CD by yes congruent rule. Okay, my children, understood this step? Right. So angle AOB is equal to angle CO dash D. Yes or no, my children? Therefore, angle AOB is equal to angle CO dash D by CP CT. Hence proved. Understood point? Understood this step, my children? Right. Now come to the question number 2. Prove that if chords of congruent circles subtend equal angles at their centers, then the chords are equal. Understood this point, my children? Understood this question? Right. Now let us assume that O and O dash are centers of congruent circles. Let us assume that O and O dash are centers of the congruent circles. And chord AB and chord CD are subtending angles at their centers. They are equal. Now we have to prove that AB is equal to CD. Understood this point, my children? Right. These two angles are equal. Now we have to prove that this side is equal to this side. That chord. Okay, it's done. Let O and O dash are let O and O dash are centers of congruent circles. Okay, my children. Right. Chords chord AB chord AB of the circle with the center O and chord CD of the circle with the center O dash are subtending are subtending equal angles at their centers. That is, angle AOB is equal to angle CO dash D. Understood this point, my children? Here we have taken the chord AB of the circle with the center O and chord CD of the circle with the center O dash. They are subtending equal angles at their centers. That is, angle AOB is equal to angle CO dash D. Understood this point, my children? Understood this step? Right. Now, if you observe the two figures, there are two triangles. Okay, my children, we have to prove that, required to prove AB is equal to CD. These two chords are of equal length. We have to prove that these two chords are of equal length. Okay, my children? Right. In triangle AOB and triangle CO dash D, OA is equal to O dash C, radii of congruent circles. Okay, my children, OA is equal to O dash C. Similarly, OB is equal to O dash D. These are also radii of congruent circles. Understood this step, my children? Right. Angle AOB is equal to angle CO dash D. It is given. Angle AOB is equal to angle CO dash D. It is given. So in these two triangles, two sides and included angle in this triangle are compared with the two sides and included angle in the second triangle. They are equal. Yes or no, my children? We have proved. Therefore, triangle AOB is congruent to triangle CO dash D by SAS congruence rule. Understood this step, my children? By SAS congruence rule, we have proved that these two triangles are congruent triangles. This implies AB is equal to CD by CPCT. By CPCT means by corresponding parts of congruent triangles. Understood this step, my children? Hence proved. Okay, my children? Understood? Right. Exercise 10.2 is over. Now come to the concepts of exercise 10.3. Okay, my children, exercise 10.3 concepts we are going to discuss now. Okay, my children, see the first point, perpendicular from the center to a chord. Okay, my children, in this exercise, we solve the sums related to this point, perpendicular from the center to a chord. See the first theorem 10.3. The perpendicular from the center of a circle to a chord bisects the chord. See this figure, my children. To understand this point, let us visualize this concept. Let O be the center of the circle. Okay, my children. AB is a chord. If you draw a perpendicular line OM, let us consider OM is a perpendicular to chord AB. Then AM is equal to MB. AM is equal to MB. This perpendicular line OM bisects this chord. Okay, my children, here OM is perpendicular to AB. Then AM is equal to MB. That bisects this perpendicular bisects this chord. OM bisects chord AB. Okay, my children, understood this point? Right. Now come to the theorem 10.4. Theorem number 10.4. The line drawn through the center of a circle to bisect a chord is perpendicular to the chord. See the figure, my children. Let us visualize this concept. Let us consider this is a circle with a center O, and line OM, a line OM is drawn perpendicular. A line OM is drawn such that it is bisecting this chord AB. Line OM is drawn through the center of this circle such that it is bisecting the chord AB. Means AM is equal to MB. Okay, my children. Then this line OM is perpendicular. Then OM is perpendicular to line segment AB. Okay, my children. Now let us prove this theorem. Okay, my children. Right. Let O be the center of the circle. Center of the circle. In the adjacent figure. Let AB be a chord of the circle. Let AB let AB be the chord of the circle. Okay, my children. Let OM, let a line OM is drawn through the center of the circle such that it is bisecting the chord AB at M. Okay, my children, understood this point. Here we have taken OB the center of the circle. In this adjacent figure, let AB be a chord of the circle. Let a line OM is drawn through the center of the circle such that it is bisecting the chord AB at M. It is bisecting. That is AM is equal to MB. Understood this point, my children? Understood this step? Right. Required to prove. What is to be proved? Angle OMA is equal to 90 degrees. Angle OMA is equal to 90 degrees. Okay, my children? Right. Or OM is perpendicular to. Otherwise, we have to prove that OM is perpendicular to. OM is perpendicular to AB. We have to prove that OM is perpendicular to AB. Understood this step, my children? Right. Let us prove this one. join OA and OB. Join OA and OB. Okay, my children. Then we get two triangles, namely OMA, OMB. Yes or no, my children? Then we get two triangles, namely triangle OMA and triangle OMB. Yes or no, my children? Here we are getting two triangles, namely triangle OMA and triangle OMB. Okay, my children. Right. In triangle OMA and triangle OMB, let us compare the corresponding parts. Okay, my children. OA is equal to OB because they are radii. They are radii of the circle. OA is equal to OB. Yes or no, my children? Right. Next, AM is equal to MB. It is already given. AM is equal to MB. AM is equal to MB. Yes or no, my children? Right. OM is equal to OM. This is a common side to the two triangles. Yes or no, my children? So, the three sides in one triangle or corresponding sides are equal. The three sides in the one triangle are equal to the corresponding three sides in the second triangle. Therefore, triangle OMA is congruent to triangle OMB by SSS rule. Understood this step, my children? Right. This implies angle OMA is equal to angle OMB by CPCT. Therefore, angle OMA is equal to angle OMB. Yes or no, my children? They are corresponding parts of the congruent triangles. And moreover, they are a pair of linear angles. It is a linear pair. Yes or no, my children? And angle OMA and angle OMB is a linear pair. What is meant by linear pair? The sum of the two angles equal to 180 degrees. Therefore, angle OMA plus angle OMB is equal to 180 degrees. Yes or no, my children? Right. This implies angle OMA plus angle OMA, because here we have proved angle OMA is equal to angle OMB. So in the place of OMB, I wrote angle OMA. Okay, my children? Right. Is equal to 180 degrees. Because angle OMA is equal to angle OMB. Because angle OMA is equal to angle OMB. That is why I wrote in the place of angle OMB, I wrote angle OMA. Understood this step, my children? Right. This implies 2 angle OMA is equal to 180 degrees. Yes or no, my children? So we transpose to RHS. Angle OMA is equal to 180 by 2. That is equal to 90 degrees. Angle OMA is equal to 90 degrees. That is equal to OMB also 90 degrees. Yes or no, my children? This implies angle OMA is equal to angle OMB is equal to 90 degrees. This implies we can say that OM is perpendicular to AB. Understood this step, my children? OM is perpendicular to AB. Hence proved. Understood, my children? Is it clear? Right. Now come to the next theorem, that is 10.5. Theorem number 10.5. There is one and only one circle passing through three given non-collinear points. Understood this point, my children? Right. In a plane, there are three non-collinear points. Do you know what is meant by non-collinear points? The 3 points are not lying on the same line. Okay, my children. So here these 3 points are non-collinear points. They are not lying on the same line. Then there is one and only one circle passing through the 3 points. Understood this point, my children? I visualized this point here. Okay, my children. Remark. You have to notice that here triangle ABC. We can join AB, BC and CA. What do you get to triangle ABC or not, my children? Yes. If ABC is a triangle, there is a unique circle passing through the three vertices A, B and C of the triangle. Have we drawn a circle passing through the vertices of this triangle, my children, or not? Yes, we have drawn. This circle is called circumcircle of the triangle ABC. What is this circle called? Circumcircle of the triangle ABC. And its radius and center and radius are called respectively circumcenter. Here the center of this circle. The center of this circle is called circumcenter and the radius of the circle is called circumradius. Okay, my children, this is OA, OB and OC are said to be circumradius of the circle. Understood this point, my children? Right. The concepts of exercise 10.3 were completed. Okay, my children. Now we are going to start the problems in the exercise 10.3. See page number 176 in the textbook. Okay, my children. See the first question, question number 1. Draw different pairs of circles. How many points does each pair have in common? Understood this question, my children? Right. What is the maximum number of common points? Okay, my children? Right. Come to the solution part. Now I am preparing a table. I am showing the solution of this question in the form of a table. Okay, my children. Here I am taking pairs of circles. Here I am writing number of points in common. Okay, my children. See here. Okay, my children. There are two pairs are like this. Two circles are. One side is outside the circle. Otherwise, or one side inside the circle. Okay, my children? Right. In these two cases, there is no points in common. Are there any points in common, my children? No points in common. Understood this point, my children? If a circle is complete outside the circle, or if a circle is completely inside the circle, in that case, no points are in common. Okay, my children? Second point. The two circles are touching each other like this at a point. Okay, my children? This point is called point of contact. Otherwise, So one circle is touching the other circle inside. Here that circle is touching the other circle outside. This is a point. How many points are there in common? Only one point there in common. Understood these two cases, my dear children? Right. Now come to the third case. If the two circles are intersecting, then the points P and Q are points of intersection. Okay, my children, how many points are in common? 2 points are in common in this case. If two circles are intersecting each other, then there are 2 points in common to the circles. Understood this point, my children? Right. Now come to the question number 2. Next question. Suppose you are given a circle. You are given a circle. Give a construction to find its center. Okay, my children, here radius of the circle is not given to construct a circle, to draw a circle. But circle is already given, but we have to find its center of the circle. Understood this point, my children? Right. To find the center of the circle, we have to do these steps of construction. Okay, my children. Let us take the points P, Q, and R. Let us take any 3 points. Let us take any 3 points P, Q, and R on the circle. Okay, my children, we have to take any 3 points anywhere. You can choose the 3 points on the circle anywhere. Okay, my children, understood this point? This is the first step. Let us join PQ, QR. Let us join PQ and QR. This is the second step. We have to join PQ and QR. Understood this point, my children? Then we got card PQ and another card QR. Okay, my children? Right. Draw the perpendicular bisectors. Draw the perpendicular bisectors of PQ and QR. Okay, my children, do you know that one? How to draw perpendicular bisector? By using compasses. Okay, my children, more than half radius. We have to take radius more than half of this length. Do you remember that points, my children? So we have to construct this like this. Another perpendicular bisector. Then these two perpendicular bisectors intersect at O. Okay, my children. Let these perpendicular bisectors of PQ and QR intersects at O. Okay, my children, this point O then O is the center of the circle. Okay, my children, understood these steps of construction. Sometimes you are given a circle, then we have to find center of the circle. Here radius of the circle is not given, but we have to find the center of the circle. In this case, we have to follow these steps of construction. Understood, my children? Right. There is one more question in this exercise. Please try yourself that question number 3 in the exercise 10.3. Okay, my children. Will you try it yourself, my children? Try it. If you have any doubts, ask your doubts and get your doubts clarified. Okay, my children? Right.